Fine. No? What's that? Okay. What's the difference between radius and circumference? Yes, you get there eventually. So a circle is basically defined as a set of points that are all equidistant from a center. Okay? Those set of points are on the outer edge. So when we deal with the circle, more often than not, we're going to deal with, obviously, the center of the circle. They label circles just like we've labeled stuff before. A lot of times this might be circle A. What they'll do is they'll just give it a capital letter and put a dot at the center. So when they talk about them, they'll say, hey, look, here's circle A. And that's how they write it. It's like an angle symbol or a segment symbol and stuff like that. They just do that. Every circle, all circles have radii. Yeah. The radius is from the center of the circle to the side. Again, this is stuff that all of you guys know. That is not anything different. From center to side.
That's an ugly circle.
Mine?
Mine.
Oh, I was going to say, I pressed the button for mine, man. I cheated big time on this one. Then you have, do you guys remember what diameter?
Yep.
Diameter goes from edge to edge through the center. The diameter goes edge to edge through the center of the circle. You probably know this as well. What is the diameter made up of? Two radii, yeah. The diameter is made up of two radii. So we usually say diameter equals twice the radius, or half a diameter is the radius, so on. Again, this is stuff that I know all of you guys have done. The other part, I think Evan said it here a second ago, circumference. You guys remember that? Circumference is always the distance around. So it's kind of like perimeter. And when you did circumference, do you remember the formula was for that? Circumference was 2 pi times the radius. Okay? And the value of pi, you just use the button on the calculator. Okay? You don't have to worry about doing any conversions. We're not doing any decimal stuff at all. What's nice when we do the calculations with all this stuff, eventually when we get to one of the things we'll do today, the calculator with the fraction bar and all, that's really all we need to worry about. Okay? The way we write it is 2 pi r. Obviously, when you write out formulas, numbers go first, symbols, then variables. That's just kind of the math etiquette way of doing things. But when you type it into a calculator, say, for example, the radius was 7, what you would do is do 2 times 7 times pi. You just flip-flop the pi and the 7 when you write it out. Right? So my circumference of the radius of 7 would be 14 pi. That's how you would write that. Just like when we did square roots, if an answer gave you something in the square root, you would left it through where we have root 3s or root 2s and stuff like that. Same thing holds here. If there's a pi, you just leave a pi in the answer. Calculations where it's really, really easy. Again, this is stuff that I know you guys have all done. We're not dealing with any areas or anything yet. We'll get to that eventually. Yes, ma'am?
So, just out of like,
you cannot be curious in this class.
so the circumference is 2 pi radius. So could you technically just put 5?
Yes, ma'am. That's the other way of doing it. Yep, that's a great thing. The other way that people will see circumference is also pi times the diameter. It means the same thing. It means exactly the same thing. Why, hello! How are you? All right. Yeah, that's another way people will do it. It depends on how you're given, what you're given as you go through. All right. Yeah. We okay on this? This stuff's the easy stuff. All right. Who's winning? You are failing miserably. So let's talk about something new then. an arc. Circles have arcs, okay? I don't know if you knew that. I know, right? Circles what happens now is we start to talk about arcs. Arcs in circles are the curve, if you think part of the curve. Okay? So we get different types. You get what are called major or minor arcs. It's kind of like, you know how we did angles where they were acute, obtuse, and things like that? It's kind of the same idea. Arcs, you can have what are called minor arcs. You can have a major arc. These are all going to be measured in degrees. Okay? How many degrees are in a circle? 3, so you were halfway there. So it's 360 degrees to get around a circle. Yeah, I saw what I did there. And what happens is, we're going to put an angle at the center. It's going to be called the central angle. I know. The central angle. The central angle is made up of the vertex is at the center, and the sides are radii. Those angles run into part of the circle. They run into an arc. Okay? So what happens is the arc then, so if this is circle A, this is, let's see, point B, point C, I could say that angle, in this case, angle BAC hits arc BC. And you put a little curve over it because it's denoting that it's part of a circle. Whereas when we did segments, remember how we used to use a little line? Arcs have a curve because it's on a circle. Okay? Now, minor arcs are going to be arcs that measure less. Oops, measure less than 180 degrees. All right. Minor arcs usually have 2 letters. Okay? Major arcs measure more than 180 degrees. Major arcs measure more than 180 degrees, and these guys usually have 3 letters. And we'll get to how all of it works here in a second. Okay. Excuse me. Ugh. I bet you know this one. What happens if it measures 180 degrees? You know what that's called?
Remember the word somewhere in the back.
Semicircle? And then the other one is called a semicircle. It's when it measures 180 degrees. When the arc is 180 degrees. What segment makes a semicircle in a circle? What's that called? The diameter. The diameter creates a semicircle because it goes edge to edge through the center. Okay. All right. So far, so good? I know this is real tough. Thanks. So, for example, here we have this angle. If this angle was, 63 degrees. If that angle equals 63 degrees, the arc that it runs into is also 63 degrees. And we'll get to that here in a second. The measure of what we call a central angle always equals the arc that it hits. All right, let's put that in a clean one. The measure of a central angle will always equal the measure of the arc it hits. Good morning. So, whenever you have a central angle, central angle, if this angle is 110 degrees, that means the arc that it hits is 110 degrees. Okay. It's really, really easy. All right. Measure of the angle equals the measure of the arc. Back and forth. All right. Super, super simple. Now, what'll happen though, if this side is 110 degrees, what would this side be? But it's a circle, 360 subtracted out, and you would go that way. Okay, so the other side would have been 250. So what'll happen here is, it depends on what they ask. You just follow basically it's a lot of following the angles to the arcs. Okay. Excuse me. Now, what'll happen here also is we'll get stuff that looks like this. Ooh, jeez, sorry. Gentlemen, cut it out. Those two segments that I drew in there were diameters. Okay? A lot of times what you'll see in instructions for this stuff, it'll say segments that appear to be diameters actually are. Okay? So it won't specifically say it, but it'll say that. It'll say segments that appear to be diameters are. Okay? Now remember, diameter does what to the circle? Cuts it in half. Okay, that's one first thing. So what'll happen is you can do a lot of angle addition also. Let's say this is 35 degrees. What has to be on this side? Aren't those vertical? Vertical angles. You get 35. To get to this angle like here and here then, careful. Now you're looking at the diameter. Yes, sir. You're overthinking it because doesn't this split the circle in half? Isn't that just a line? How many degrees are in a line? 180. Are you wrong though, Sam, for what you're saying? No, you're not. It's just a little bit more work. Can I just take 35 from 180? What do you get? Numbers. 145, which means the other side would also be 145.
I see why you're talking about that other stuff right there.
Okay. Now, let's go through this then. Let's label our points here. Let's say it's A, B, C, and D. Everybody okay that we have 4 points on the edge of the circle now? You all right with that? So, let's say I wanted to figure out what is the measure of AB. When you see this, you'll have it written with an M in front of it, and then the arc. So if I want to say the measure of AB, what would be the measure of AB?
35.
35, good. Okay. Correct. What if I do this? If I say measure of ABC. It's 180, isn't it? Yeah. What happens with the arcs when you get to 3 letters? It tells you what direction to go. It starts at A, go to D, finish at C. It tells you, it's kind of like an angle, how it has the middle letter being the vertex. But here, when you're on an arc, it's telling you which way to go around the circle. Okay? It's just telling you which way to go. So ADC has to equal
180.
180. Okay?
That's a major. Wait, no.
Semicircle.
Draw.
All right. What about this? Measure of A, B, A, B, D. That's a major arc. Good. If I want to say A, B, D, again, I'm just following the letters around. I start at A again, and I follow around to D. Well, going all the way around that way was 180 and then some. So to that 180, what do you add? The 35, you get 250. Okay. Pretty simple, isn't it? Notice how you're just adding, just like you have before with angles. It's the same basic principle. Right? Yeah. Sure. Bless you. We just did that. Got ahead of myself here. Oops. Oh no. Oh no. More pixel, I know. Let's say I want to figure out what's the measure of arc TQR. Do I have enough information to figure that out?
I mean, you could.
What do you do?
I don't think.
Okay, so there's my
Radius.
Yes, sir.
Would you do 360 minus 50?
Correct. Take a look at what it is. Measure of the arc here. I'm trying to figure out the arc, and I'm trying to go this direction, TQR. If I know,
Read that.
that's okay. If I know the one chunk is 50, all the way around it, then it's got to be 360 subtracted. And you get what? 310. Okay. What's that? And while it does work like that, it doesn't. Because it's a diameter. Diameters always create 180 degrees. Okay. Not switching. Yes. All right. What are you doing? Okay. All right, let's try a couple of these then. Let's try a couple examples here. Like I said, the start of this stuff is relatively straightforward. There's not a lot of craziness here. It works out rather cleanly. Again, things that appear to be diameters are, okay? You'll see that instruction a lot. So in this example here, it looks like CA is a diameter. Okay? So if you have CA as a diameter, if CD is the 58 degrees, what has to be on the DA portion? What would you do first? If you know this is 50, if the arc is 58, that means the central angle is 58, which means this side would be 180, subtract that. 122, very good. Here you've got the central angle at 32, which means the arc has to be 32, because they're the same. Which means this arc was 122. And then as you come around the circle, I back out 32 from the 180 and you got 148 from the other side. Okay? From here, it's just following letters. What's the arc BC have to be? 32. What's BD have to be? There you go. All right? ABC. Good. And then AB. See how easy this is? All right. This is why we like to start with this. That's why I always like to start with this section first, because there's really not that much to it. What's it? Yes, sir. Probably not until next week. My guess is probably like Tuesday, Wednesday, something like that next week. I have to look at my notes, what I have written down. Usually we go, I think we get through 12:3 before we do our first one, because then it gets into, we try to stick with all the angled portions of things. What's that? This is 10. Remember I said earlier we switch around a little bit? I want to, because in 12 you use a lot of this material of terminology and stuff, but they teach it in a different part, which makes no sense. So, not the biggest fan of the way this book does things. I don't know. Have you noticed we haven't used the book at all second semester yet? Have you noticed that?
Right.
I don't think we need to know what to do. Once again, circumference. Circumference was what formula? Do you remember? Circumference was 2 pi times r. Pi r squared is area. Okay. Or pi times the diameter. Okay. Again, when you're dealing with circumference, this is where things can get a little weird. So we're gonna do one other part of this here. Circumference is the distance around a circle. Okay, this is the perimeter part. So if you have your circle, you have a radius of 4. Your radius is 4. Your circumference would be 2 times 4 times pi. So circumference would be otherwise known as a pi. Okay. Now remember, that's distance. Okay, that's the distance. The other part of this that we're going to talk about is what's called arc length. Okay, arc length is the second part of this, where arc length comes into play. Oh, did you need that back? All right. So arc length is going to be a portion of the circumference. Okay. Arc length is part so arc length is the distance you'd have to walk on a circle. Okay. Arc length is not an angle, it's a distance. Okay. It's made from part of the circumference. You have some angle here that runs into an arc. Okay. So it's a portion of it. How do we find that portion? Well, we have to figure out what the angle was. We have to use the angle to figure all that through. So there's a formula for this. It's really easy. So, arc length. Is always going to be central angle, excuse me, over 360 times 2 pi r. All right. Arc length is always central angle over 360 times the circumference, 2 pi r. No? What if I told you this?
No.
Okay. So obviously you'd have to know 2 things to make this work. So if I say this is 110 and the radius is 6, all I do is put it in my calculator. So you have your central angle, 110 over 360 times 2 times 6 times pi. Yes, ma'am.
Is it still okay to use the
Yeah, if you want. I try to stick with you guys with the central angle stuff. I try to use just that, but if you use theta, it's no big deal. All right. So what's nice with the multi-view calculators again is that we have fraction marks. We've got the pi button. We've got all that stuff. So you can, once you get to this, you're literally just typing it in the calculator. There's a button for it. I'll show you. 110 over 360 times 2 times 6 times pi. The pi button is right next to the sign. Okay? And then you hit enter. And there's your answer. 11 pi over 3. That's it. What's that? Leave it in terms of pi. Do not press any buttons. You do not need decimals. Okay? Can you find the pi button on that one? I think what else is down there. Okay. Now again, remember, guys, this arc length stuff It's a little weird. It's different than, okay? There's 3 different ways this can be written out then. If you start thinking about what you have, arc length was the angle over 360 times 2 pi r. That's circumference, isn't it? So you can write it as angle over 360 times the circumference, or what's twice the radius called? Or you can write it as angle over 360 times pi diameter. So depending upon what information you might be given, you can use either one of those formulas, or either like one of those 3. So if you were given a diameter, I would find half of it and double it and go that way. I'll just use this one right off the bat. There's just 3 different ways it can be written out. So, I'm sorry. Yes, sir. Yes, sir. So, for example, I had one up here, didn't I? What's that? Pi times diameter. Where's that one? Well, I guess these guys are. Oh, yeah, here. So, in this example here, I want to find the arc length. What's my central angle? If it was 23, it would have a degree symbol, wouldn't it?
Oh, you're right. So you gotta divide it halfway.
Oh. So what's the central angle in this case? 180, good. Is that 23 a radius or a diameter? It's a diameter, okay? So in this case here, your angle is 180, and you're given a diameter of 23. This is why we have the different versions of what you've got, so you can just use angle over 360 times pi times the diameter. So you put all that together, you get 180 over 360 times 23 pi. What's 180 over 360? It's half, right? So wouldn't this just wind up being 23 pi over 2? And it would do that also. But a lot of times, if you understand how to work with fractions real quick, it's just faster. Sometimes, yes, you're right. It's been known to happen. So I wasn't wrong. You were not. Okay. Now remember, there's a difference between what they say arc length versus measure. Okay. Measure, when you have the measure, that's when you're finding the actual angle. The arc length is when you have to piece it all together. Hi. You don't want to, all of them.
That's true.
Because if you know what circumference is, then you know it's pi r, 2 pi r. You know that, you know the other ones. So it's usually really, really easy for you. All right. And did that. Let's see here. We'll do one more arc length. The arc length they're looking for here is this part. We'll do one more and we'll call it a day, and we'll do some props. All right? One more arc length, please. Yeah, that's what I should change. What's that? 25? Okay. That's okay. It could be. Remember, as you put this stuff together, what's your angle here? The angle here is going to be the 240. Okay? Remember, arcs and the central angles always measure the same amount. So if the arc is 240, your angle is 240. And then it's times 2 times 15 times pi. Okay? Sam, you said you threw it all in the calculator. What'd you get? 20 pi? Anybody else get that? You zip this through. This becomes 18 divided by 3 gives you a 6 and an 8. And wait, that's not 8. Yeah, it is. That'd be 2, 3, 4, and then 60. Yep, 25. So that goes to 5 times that. Yep.
You didn't use a calculator.
Math. No, they work pretty quick. These things aren't too crazy. What I did was I kind of piecemealed some of these things between the textbook, but I made a copy of it because we all know reading things on the screen is kind of tough. So take a look at these here. Ladies and gentlemen, fun. Take a look at these things through here. You'll notice that they are really easy. Okay? So I'm not really worried about 9, 10, and 11. It's okay. It's okay. Now, here's what I would do. If you look at the next screen of that 12 through 23, here's what I would always do when I have a big one problem, one diagram with multiple questions off of it. I would go to the diagram, diameter 90 and 128.
Crazy.
Thank you. So from here, when you look at that diagram, you can figure out everything else. If this side's 90, what's that side? 90. So you have 90 here and 90 here. TD has to be a diameter. So you subtract that from 180, or take 180, subtract out from 128. What are you left with? 52 for over here. From just that bit, then you can answer every single one of those questions, just a matter of adding them up. Okay? Really easy to work with. Okay. Let's see, circumference are the next couple there. Arc length, the bottom. And on the back, it's some more central angle stuff. Really easy. And then I'll leave the algebra up to you so you guys can figure that out. I have no doubt you'll be all right. Okay? Yeah, you guys go knock this out. This should not take very long. Actually, most of you probably get at least that first page before you walk out of here. All right. Yeah. I would suggest, ladies and gentlemen, put your arc length formulas out there because you'll use them. That way you have it for you because it just wants you to say that we go from there. Okay? Don't forget, tomorrow is National Makeup All Assessment Day. Merry Christmas. Make sure that you, this is everybody's favorite holiday. What do you want? What? So don't forget, it's National Makeup Assessment Day tomorrow, March 3rd. Wait, say the 3rd? No, tomorrow the 3rd. So make sure that you run out and you buy plenty of gifts and get a card. I wouldn't be surprised if Hobby Lobby already has their decorations up for National Assessment Makeup Day. It's probably right next door to the 4th of July stuff they probably already have up.
Yeah, 4th of July.
No, there's St. Patrick's Day. Yeah, St. Patrick's Day first.
But remember, they'll have all the Christmas stuff up again right after 4th of July. Gotta beat the rush.
I know when I get like,
Right. Yes, sir. Yes. Yes, sir. No, don't worry about it. Yeah, don't worry about that. Get everything else though. I didn't cut that part out.
Give me this,